Okay, final video. We just have a few questions left. Question 16, find the area under the standard normal curve that falls, to the left of negative 0.34. So remember, zero's in the middle. Negative 0.34 will just be a little bit here to the left. And we want the area, because the area is the probability, is the proportion. Which is going to be less than half, but just a little bit. All right, we know it's the standard normal curve, so we have a normal distribution with mean 0 and standard deviation 1. So my lower limit is negative infinity because I'm going to the left. My upper limit is negative 0.34. 0 and 1 are my mean and standard deviation respectively. And of course we get less than half, like we said, 0.36692. We'll just round that. Find the area under the standard normal curve that falls outside. So that's 1 minus the probability that it falls in between. So my lower limit for the inclusion is negative 0.34. Right, if you think about this, negative 3.4 is way over here. So we want just that little bit, which is almost nothing. And 1.1, all of this. So the way I'm getting this answer is by subtracting this middle part out of it, right? So after I subtract, we end up with, in question 17, 0.1360. All right, number 18, probability that standard normal distribution, let's just repeat that. Mu is 0, sigma is 1, and of course it is a normal distribution, so we follow a normal curve, but standardized with mean 0, standard deviation 1. Okay, in question 1, we get 0.7823. We saw one like this earlier. In question 2, we change our lower limit to negative 1.33 and our upper limit to 2. And we get 0.8855 when we round. So just to show you what we're doing, for example, in B, we have a normal curve. 0's in the middle, 1 is about where that inflection point is, and negative 1 is the opposite. We want the probability that you're between negative 1.33, so negative 1 1/3, all the way up to 2. So even though this curve goes on forever, it gets closer and closer to this axis like an asymptote. And I want the total area in red, which is pretty much a majority. It is a majority, but how much? Well, it's 0.8855 if the total area is 1. All right, in C, we're doing less than negative 0.55. or greater than 1.95. So remember, this would be 1, so this would be 2, and this would be right near 2. Well, so we're going to subtract this excluded part from 1. So it's 1 minus the probability that z is actually between these guys. All right, so that's my method here. 1 minus this excluded area. Lower limit's negative 0.55 for the excluded area. My upper limit's 1.95. Remember, the mean is 0 and the standard deviation is 1. And we're going to get 0.3167. All right, now we're going to have to work backwards. Find the probability that your answer will be 0.453 if you go greater than A. So we have a value for my area. Now I made it close to half. A will be the cutoff right here. So A is near 0 but positive, right? Because it has to be almost half, right? That's almost half. And since it says Z greater than A, I shaded to the right. That's how I know I'm on the right side of my bell curve. Well, when you want to do this, you need to look on a standard distribution table or use something on your calculator known as an inverse norm. So I'm going to do the inverse norm. I want the area to the right to be 0.4503 or the area excluded to the left to be the complement, 0.5497, depending on how your calculator works. 5497 is the area to the left. That's how the tables and a lot of calculators figure this out. So this number is very important because the algorithm, the process usually uses the left number. And we find out that this A is about 0.1249. We'll say 125. Okay, thank you for watching this video. I hope this was helpful. Let me know